So in graphing this, we start by moving it down 8. And then once we've moved it down 8, I can now go ahead and use the 2. This is where the stretch starts once we plot our first point. So instead of going our normal over 1 up 1, because remember that's what we normally do for a quadratic, because 1 squared is 1, I'm going to double that height. So instead of over 1 up 1, I'm going to go over 1 and up 2. Because I'm always going back and saying, what do I normally do? And I'm just doubling the height. So then for the next point, normally, I next go over 2. And then, what's 2 squared? 4. Because it's 2 times itself. And so normally I go over 2 up 4. But in this case, I'm not going to go up 4. I'm going to go up 8. Because I'm multiplying whatever I normally go up by whatever number is multiplied by the x squared. All right, next up. Normally, I'd go over 3 and up how far?
Up 9.
9, yes. Because 3 squared is 9. So in this case, I'm not going to go over 3 up 9. I'm going to go over 3 and up twice that. 9 times 2 is 18. So I'm going to have to go over 3 and up 18, which, yes, just does fit on your graphing grid. Now, since that barely fits on the graphing grid, as you might expect, the next one would not fit on the graphing grid, so we can go ahead and draw our curve that goes through those points. And then just to show you what that 2 is doing, here I've sketched in a light red what the original graph would have looked like. So that's the graph just of x squared minus 8. Notice what the 2 is doing. The 2 did not make it necessarily like half as wide or twice as wide or anything. It truly is affecting only the up and down part. So instead of going up 1, it goes up 2. Instead of up 4, it's up 8, and so on. It doesn't look twice as high when you first look at it necessarily, but when you go point by point, you see that it is in fact twice as tall at each point. All right, write this equation now above your next graphing grid. This is the last one we're going to be doing together today. And again, we start by doing any shifts. So the x plus 1, the plus 1 in there, since it's in with x, I know that it's going left and right. And plus, remember, always goes left. So I'm going to go left 1, and then the minus 7, it's hanging on the end. And whenever we have a number hanging on the end, we know that moves it down. So my very first point is going to go left 1 and down 7. So there's our first point, left 1, down 7. Now from there, instead of over 1, up 1, I'm going to go over 1 and up how far? Yes, 3. Because I'm multiplying my normal ups in this case by 3. So on both sides, go over 1 and up 3. Next up, you're always thinking about what would I normally do next. So I think normally I would go over 2 and up 4. In this case, though, I'm not going to go over 2 up 4. I'm still going to go over 2 because it doesn't affect the over at all. But instead of up 4, I'm going to go up how far? 12, yes, because I'm doing 4 times the 3. Remember, because I'm always multiplying by whatever that number is there. And so the 4 times 3 gives me 12. And so then that's over 2 and up 12.
Can we fit?
The next one, what would the next one be? Let's see if it fits. Normally, it's over 3 and up. Remember, 3 squared is 9, so normally it's over 3 up 9. What's 9 times 3? 27. Can I go up 27 from that point and fit it on my grid?
I don't think so.
No, I can't. So go ahead and draw the curve that goes in through those points, and then you are done.